Hello, everyone. This is Coach Weaver. Good morning, good afternoon, good evening, whenever you watching this. Um, this is going to be one of your lessons that you guys are going to do this week. We've already discussed static electricity and electricity to some degree early on, and I know that this was a crazy couple of weeks, but this lesson that I'm going to lead you guys in is more of a review of what you guys have already done and what you already know. This is a Nearpod. The Nearpod will be posted up, I believe, on the in your assignments. So please get to that Nearpod after watching this video. But all I'm going to do is just go over everything again that we've already talked about. I'm not going to go over every slide on this, but there are activities such as a poll and like share what you know and things like that on here that you guys, I would like for you guys to participate in. But mainly I'm just going to go over all of this. A lot of it, again, it's just a review. So watch it, hopefully, and answer some questions that you may have had, and you may learn something new if you didn't get it the first time. So this is just going to be an overview over static electricity, what we did early on. So, this is one of such a questions on here. Where do we see science in our everyday lives, guys? So you do science every day. You experience all the time, and you can't get away from science, man. Like, this is what you do. Hopefully you'll be able to, recap over things about static electricity, positive, negative charges, things like that. And then like in a lab that we did where we rubbed a balloon on our hair, we rubbed it with fur and other things, again, hopefully you get that review over what we've done before. So again, this is a slide that was already on here, but again, we're just going to review. So right here you have a quiz. It's more like a poll. Electricity is always visible, like in light bulbs or lightning. You're going to go in there and you're going to answer that poll. Tell me what you think. If you're not sure, true, false, or no answer. Is electricity always visible? So start doing that. On this slide right here is a collaborate board. Just talking about where some places where you see electricity. Guys, man, there's electricity everywhere. It's kind of like that thing when the power goes out and it just sounds quiet. It's because the electricity turns off. For electricity is everywhere. Okay. Here's a video. It's a cool lab, cool activity that you can try at home. You don't really need everything. Just get you 2 styrofoam plates. Watch that video. It's pretty interesting. You can make a styrofoam plate hover like it's floating in the air. It's pretty cool. So you guys need to think about that. Also in this thing pair share, maybe write this stuff down. Any questions that you may have. So when did you see things moving? When did you see them move apart? Watch that video. You'll be able to answer those questions. So again, static electricity, guys, it's something really simple. The example that we use is when you take your clothes out of your dryer, and why do things stick to each other? And the main reason, guys, is because there's going to be a positive or negative charge or a transfer of electrons. So what we're going to do is look at a FET lab. This is the FET lab. This is the main thing that we want you guys to get out of this video. On the next slide is actually going to be the lab itself. And in this lab, guys, what we want you to do is to follow those directions from the previous slide. So in here, we're going to rub the balloon on the sweater, and we're going to see how does the charge change and how does the charge move. When you look at the sweater, we're just going to say this is a wool sweater with a rubber balloon. So if you guys remember on your triboelectric series chart, you have certain things that want to take more electrons, and sometimes it wants to take more electrons to be more negative, and some things wants to give more electrons to be more positive. And sometimes you'll have that done to you in your everyday life. So in this FET lab, we're going to see this balloon is made of rubber. Rubber on the triboelectric series is somewhere towards the middle, towards the bottom. It wants to take more electrons. This wool is a little bit higher up on that triboelectric series. So if we go in here and we Google triboelectric series, and I'm gonna pull up an image. Here's a really good image right here. So if you look over here on the right, we have wool. Wool is more at the top. Wool is more at the top, meaning it wants to be more positive. It wants to give away its electrons. As you keep going further down and down and down, you'll see rubber. Rubber's near the bottom of this triboelectric series, meaning it wants to take more electrons, more negative charges. So it wants to be more negative than the wool that is interacting with. So when you look at it, as we rub the balloon on the wool shirt, you see that the wool shirt gave away all of its electrons and the rubber balloon took the electrons. So if I put the balloon right here, you see that it's attracted. So now we're talking about how opposites attract. Those are things that we see in our daily lives. Positive and negatives want to come together. If it's two positives or two negatives, we know same charges want to repel. And that's what you see here. You see opposite charges want to attract. And you also see how on the right side, as we bring the balloon to the wall, you see how the negative electrons are trying to move away from the balloon, because again, opposites want to attract to it, negatives or similar charges want to repel. And that's what you see on the wall right here. I think it's pretty cool how if you reset it all, right now it's kind of balanced. So the balloon, there's no charges on the wall that's being repelled or attracted, and it's the same thing. The balloon is not being attracted left or right to the sweater or to the wall, but again, we go like this to the balloon, we rub it on the wool, I place it right here, you see how it's attracted to that wool shirt, and then you also see how the negative charges or the electrons repel, and it doesn't want to be close, and it's actually supposed to be sticking to this wall, and that's what you see right here. So play with that lab and activity, and and you get a better explanation, and hopefully you get a personal thing from this that make you go, oh man, I get it. So the biggest thing is we want you to get it. So play with that FET lab. So after you play with the FET lab, we want you to in here draw a picture. I know that sometimes you may or may not be able to draw pictures on here, so I recommend that you probably draw it on a piece of paper, or take a picture of it and upload it on the team site to your respective teacher. Same thing here, draw the electrons inside the balloon and the sweater after you rub them. So do that same thing. I would draw a picture and upload it, or you could do it on here. All right. So again, this is just a big overview. And again, like I said, all of this is just one big review. Static electricity, again, we know that atoms are made up of protons, neutrons, and electrons, and they all have their own charge. This is a big thing, because sometimes you guys like to mix it up. Protons, positive. Protons are positive charge. Electrons have a negative charge, and neutrons have a neutral charge. Okay? Protons are positive, electrons are negative. The biggest thing when it's talking about electricity, guys, is electrons. Electrons are very important. Electrons, if you've taken chemistry, you should know this, but electrons are the only thing that moves in an atom. They're the only thing that move. So when we ask a question, what moves in an atom, the answer should be electrons. How can I make something more negative or more positive? There's got to be a transfer of electrons. So that's the biggest thing. Okay. Static electricity is just a result of an unbalanced charge, whether the atom is positively or negative charge. There's again that negative, those electrons being moved to make something either positive or negative. And this is what we talked about here. Opposites attract, like charges repel. Okay, if I got two positives, they're going to go away. Two negatives, they're going to go away. But if I have a negative and a positive, then they're going to try to come together. And again, you see static electricity when you rub certain things together, which creates that energy transfer. Okay, you guys like to say friction. Friction is very important when we're talking about creating a charge or a transfer of electrons. But friction isn't just the only thing. Okay, electrons need to move. So again, it says when an object is positively or negatively charged, it is attracted to the object. All right, so we go back. If we go back to our balloon activity again, whenever we took the balloon and we rubbed it, we took away all of its electrons. As you see on the shirt, all the protons are still there, and now that balloon and that t-shirt are attracted. They want to stay together. They like to hang out. That's how I like to think about it. Okay, so again, when it's charged, it's attracted to the object that it charged to and repel from objects with the same charge. Okay, so another drawing activity. So you want to look at the balloons. Look at the balloons right here in this picture, and we want to know, do we think they'll float or float together or push apart? So we're talking about the balloon. So we're talking about the yellow and the green balloon. As you can see, these two guys have a lot of the same charges. So we want you to tell us or draw us, what do you think will happen? Again, I recommend you probably do these drawings on a sheet of paper and submit them to your teacher. Okay, so obviously this is right here is a negative charge. Okay, this image shows a negative charge. So we want you to draw what kind of charge that will make this push away from it. Okay, on the left, draw a type of charge that will move away from it. So over here, we want you to draw an image that's going to push away. On the right side, we want you to draw an image that's going to attract to it. Here's a hint. What kind of charge on the left side is going to make it be a repel, and what kind of charge on the right side that's going to make it attract. That's what we want you to draw. Again, I recommend doing it on a sheet of paper. And again, this is a lab that we did in class. So we want you to draw the negative charges on the balloon and then draw the correct charges on the hair. So what kind of charge would the balloon be? And then what kind of charge would your hair be? So just like in the wool shirt in the balloon FET lab, look at that and you should be able to draw the charges that you should get. There's a quiz that you're going to need to take. So I couldn't see it pop up right here, but there is a quiz. So make sure that you guys take that quiz. Again, as you see, it's only 4 questions. No one's taken it yet, so by the time I recorded this, but it's only 4 questions. Make sure you take whatever quiz that is provided to you. Okay, so here we're going to elaborate what we've learned, basically review. So again, guys, when we're talking about static electricity, we just know that is a changing of the charge or a transfer of electrons and how when it interacts with other things. Okay. So again, this is another video. We've done something like this, I know, in Miss Hobby class, but you're able to see how objects move when an object is charged. We did something like this with Miss Hobby class when we touched the Van de Graaff and we put our hands over the pieces of paper and it looked like they were floating. And this video is going to show some things like that. There's another collaboration board. Again, we want you guys to watch that video and then be able to respond right here. And then we want you guys, after watching that video, draw signs to show the negative charge on the glass, then draw an arrow to show where the sugar moved, and a sign to represent the charge of the sugar. So just like with the wool shirt, we want to see the negative charge on the glass, and then we want you to draw an arrow to show the direction where the sugar moves, and a sign meaning positive or negative, a positive charge or negative charge, to show the charge of the sugar. Okay, so I repeat, your glass is going to have a negative sign, a negative charge. You're going to draw an arrow like a direction to show where the sugar moved, and then from there you're going to draw what kind of charge does the sugar have. So there's another thing, pair share. We want you guys to think about these questions. What kind of charges attract? What kind of charges will push apart or repel? And what do you think was the charge of the sugar in that activity? So again, this is kind of already gave you the answers right here, but there's a fill in the blank. That's unfortunate. So if you watched this video before you did the Nearpod, you should have the answers. But opposite charges attract, like charges repel, and neutrons have a neutral charge. That's very important. That's very important when dealing with electricity. There's also another quiz that you guys need to take. Please take that quiz. Again, as you can see, it's only 3 questions. And then we want to know, how do you feel after you do this Nearpod activity? How do you feel? How well do you understand static electricity? Again, guys, like I said, it's more of a review than it is a true lesson. But we just wanted you guys to get back into the swing of things. I know this is a crazy time and unfortunate, but guys, be strong during this time. Remember that you do have work you need to do, and if you have any questions, please don't be afraid to email your respective teacher, whether it be myself, Miss Hobby, Mr. Register, or Mr. Smith. Make sure you reach out to us, and we will be available throughout the day. All that information should have went out this morning, but just be prepared to work. Take advantage of the time to work from home with minimal distractions, and like I said, just always feel free to email or reach out to us if you have any questions, if you don't understand anything, and we will do our best to get back with you as soon as possible. Thank you, guys. Hopefully this video helped you out a little bit, and see you the next time. Peace.